Valley of Leon, Spain, in the ancient Roman province of Hispania Tarraconensis. Researchers from the University of Salamanca strapped a LiDAR system to an aircraft and flew it over what looked like ordinary countryside. Rolling hills, dense vegetation, quiet farmland. But when that laser punched through the tree canopy and mapped the ground beneath, what came back was staggering. An entire gold mining network emerged, complete with river diversions and hydraulic channels, built by the Romans in the 1st century BC. Infrastructure so vast it had remained invisible to every previous survey, every aerial photograph, every pair of human eyes that had gazed at this valley for centuries. And this wasn't some small operation. This connected to Las Médulas, the largest open-cast gold mine in the entire Roman Empire. A site covering over 2,000 hectares where more than 90 million cubic meters of earth were ripped from the ground. For context, that's enough debris to fill about 36,000 Olympic swimming pools. The main pit alone stretches across more than 10 square kilometers, and the working face on a subsidiary pit called La Frisga spans over 600 meters wide. The Romans weren't alone in this type of mining. They used similar techniques at the Dollacothe gold mines in Wales, but Las Médulas represents the pinnacle of their hydraulic mining expertise. But here's what makes this truly insane. They didn't use dynamite. They didn't use heavy machinery. They used water. The technique was called ruinomontium, Latin for wrecking of mountains, and it was described in 77 AD by Pliny the Elder, who actually served as procurator in the region and witnessed it firsthand. Here's how it worked. Miners would first dig narrow tunnels and galleries deep into the heart of a mountain. These shafts honeycombed the rock, weakening its internal structure. Then they flooded the entire system with water. Now, water's a non-compressible fluid. That's the key to everything. When water rushed down into those sealed galleries at high speed and hit a dead end, it had nowhere to go. It stopped instantly. And that sudden braking created an enormous water pressure wave, following Pascal's principle of hydraulic pressure transmission, the same principle behind the loud bang you hear when you shut off a faucet too quickly. That's called water hammer, and the Romans weaponized it on an industrial scale. The pressure wave would fracture the already weakened rock from the inside, and entire cliff faces would collapse in a catastrophic avalanche of stone and earth. Pliny himself captured the scene in his Naturalis Historia, writing, "The third method will have outdone the achievements of the giants. By means of galleries driven for long distances, the mountains are mined by the light of lamps. The spells of work are also measured by lamps, and the miners do not see daylight for many months." That's not poetic exaggeration. These miners lived in darkness for months at a time, carving tunnels by lamplight, knowing that at any moment the mountain above them could come crashing down. But collapsing mountains was only half the engineering challenge. You need water to do this, and you need a lot of it. The Romans required up to 100,000 cubic meters of water daily. To put that in perspective, that's about 40 Olympic swimming pools worth of water every single day. So they built one of the most extraordinary hydraulic systems the ancient world ever produced. Over 400 kilometers of water channels. Some individual channels stretched more than 100 kilometers from their source. These weren't crude ditches either. They maintained a precise slope between 0.6 and 1%, or about 1.28 meters wide, widening to 1.6 meters on curves, and roughly 90 centimeters deep. At least 7 long aqueducts tapped into streams at various altitudes. One canal alone, drawing water from the Cabrera River, ran for over 140 kilometers. At the top of the mine, massive reservoirs held 18,000 cubic meters of water, ready to be unleashed. The entire hydraulic network reached 600 kilometers. That's roughly the distance from New York to Detroit, built 2,000 years ago, by hand. And what did all this infrastructure produce? Gold. Pliny reported that 20,000 Roman pounds of gold were extracted every year, about 6,560 kilograms annually. Over 250 years of operation, the total haul reached an estimated 1.64 million kilograms. This gold wasn't just for jewelry or decoration. It was the backbone of Roman currency. The timing of Las Médulas exploitation coincided exactly with Emperor Augustus's monetary reform, which introduced the golden aureus, a coin weighing 7.79 grams, as a permanent fixture of the Roman economy. This mine literally funded an empire. The peak of operations came under Emperor Trajan in the early 2nd century AD, when 60,000 workers labored at the site. And these weren't slaves, according to most historical accounts. They were free workers. Though the historian Diodorus Siculus, who documented conditions at various Roman mining operations a century before Pliny, painted a grim picture of the conditions in Roman mines, describing men who sacrificed their lives under brutal circumstances. By the early 3rd century AD, the Romans withdrew, leaving behind a devastated alien landscape. And here's a detail that really puts the environmental impact in perspective. Ice core samples taken from Greenland show that atmospheric lead pollution peaked during the Roman period. Those pollution levels from Roman mining weren't reached again until the Industrial Revolution, 1700 years later. The Romans were polluting the atmosphere on an industrial scale before the word industrial even existed. Now, what makes the recent LiDAR discoveries so revolutionary is what they revealed that we couldn't see before, as lead researcher Javier Fernandez Lozano explained. Unlike traditional aerial photography, this airborne laser detection system allows the visualization of archaeological remains under vegetation cover or intensely plowed areas. The LiDAR confirmed that the volume of Earth exploited was much greater than anyone previously thought, and that the Romans achieved actual river captures and redirections across the valley. They didn't just mine a mountain, they re-engineered an entire watershed. This technology, originally developed by NASA in the 1960s to study Arctic sea ice, works by firing laser pulses from an aircraft and measuring how they bounce back. The data creates incredibly detailed three-dimensional maps of the ground surface, even beneath thick forest canopy. The Area Valley study was actually the first geoarchaeological project to use LiDAR in Spain, and it's since inspired similar surveys at hidden mining sites across Europe. Las Médulas was declared a UNESCO World Heritage Site in 1997, though not without controversy. During the deliberations, a representative from Thailand questioned whether a site created by such massive environmental destruction deserved recognition. The committee ultimately decided that the historical and engineering significance outweighed the ecological damage. But the story isn't over. In August 2024, wildfires swept through the Las Médulas natural area, burning an estimated 1,500 hectares within the World Heritage Zone. The damage was so severe that UNESCO could potentially place Las Médulas on its list of World Heritage in danger, the first step toward possible declassification if urgent protective measures aren't taken. Meanwhile, the concept the Romans pioneered, large-scale hydraulic mining, was essentially forgotten for over a millennium when it was independently reinvented during the California gold rush in the 19th century. The environmental devastation it caused was eerily similar to what the Romans left behind in Spain. So the next time you hold a gold coin or look at gold jewelry, remember this. 2,000 years ago, an empire built a machine out of water channels and tunnels that could eat mountains alive. They reshaped hundreds of square kilometers of landscape, moved 90 million cubic meters of earth, and pumped enough lead into the atmosphere to leave a chemical signature in Arctic ice that scientists can still detect today. And we only just found out how far it all really went because someone pointed a laser out of an airplane window and saw what the forests had been hiding all along.